Good day everyone and welcome to our channel. My name is Maria Kambinda and we are going to talk about data communication. This is one of the topics that was drawn from the grade 9 content. So let us look at the specific objectives that are to be covered in this topic. The first one is we are going to define the term data communication. And the second one, to distinguish between receiving and sending devices. The third one is to list the hardware and software needed for communication. Number 4, to describe how data is transmitted and received. Number 5, describe how errors can occur during transmission of data. And the last one is to describe how data can be checked for errors. So let's define the term data communication. Data communication is the electronic transfer of data, instruction, and information from one location to another. So in simple terms, we can say it's a process of sending and receiving information from between two or more devices like computers, cell phones, servers, through medium like cables, radio waves, or fiber optics. And we can also say data communication is basically how different devices talk to one another. For example, when you send a WhatsApp message to a friend, or when you watch a YouTube video, or when you download a file. So now let's look at our specific objective number 2 that says distinguish between receiving and sending devices. So in a sending device is this is a device that gives an instruction to transmit data or instruction or information to another device. Or we can say this is a device that starts the communication by creating and sending the data. For example, we say laptops, phones, and so on like that. When you send a message, a WhatsApp message to a friend, meaning the phone that you are using is it's a sending device. Okay, so a receiving device it's a device that accepts the data, instruction, or information. Or we can say it's the device that gets data or interprets it. For example, a desktop computer, smartphone, and so on like that. So when your friend is receiving your WhatsApp message that you've sent, so your friend's phone, it's going to be called a receiving device. Okay, so I hope it's clear. Let's go and continue with our next objective of this lesson.
Greeting everyone, my name is MK Funa. I'm going to bind my slide with the last presenter. Actually, in order for us to make the data communication successful, there are tools which is needed or equipment which is needed in order to convert that specific data to the receiver. So when we talk about tools needed for data communications, are actually divided into two categories. There are tools which are found in hardware and tools which are found in software. So let's understand the term hardware and software. So as I'm pointing on this term, hardware, it's actually defined as a physically equipment or devices that involve in transmissions and processing of data. And when we talk about software, it's actually the program or the protocols which actually help to manage, control, and facilitate the data communication process. Now here we listed some of the examples in each category or in each class of the data communications. In hardware, we find internal modem, external, and ADSL adapter, which is asymmetric digital subscriber line, telephonic link, and integrated services digital network, which is ISDE adapter. And in software, we have email programs, communication software with its example like Skype, SMS, MMS, and instant messaging, which is IM, and internet relay chat, IRC. So in this slide, it broke down the process that we use to communicate data so that the receiver gets the data or the instruction that the user insert in the computers. So the sketch demonstrated the informations into simple ways. When we talk about the sender, actually has a certain functions that we wait from the sender, such as data preparation, encoding, and then instructing. When we talk about data preparation in sender, is actually we use either a text, video, or audio, because this is the first converted information into digital format or a sequence of binary numbers. So as we all know that the computer, it accepts instruction from the user, and that instruction is computed to a computer language which we know a binary format. Then that language, when they convert the information is converted to a computer language, it's actually being encoded. Then they transmit or process the information and send it to the transmission medium. This is the third part of how we transfer data communication. So what does this second part of transmission medium? We talk about the wired things or the networking digital that we use in order for us to transfer these data for communications. Example, we get internet cable, we get Wi-Fi, we get Bluetooth, and many more. Then that's the second part. And when we talk about the third part of the data transmissions, we talk about the receiver. What is the purpose of the receiver in data communications? So the purpose of the receiver is for signal receptions, decoding, error checking and resembling, data usage, and also absorption of the data which is being processed at the transmission manager. When we talk about the signal reception, this receiving of device detected in incoming signal, which we spoke like, such as like Bluetooth, Wi-Fi, internet cables, and many more networking digital options. And when we talk about decoding, these are signals that are converted back into the computer language, which is a binary data zeros and one. Because as all we know that computer can only understand binary language, zeros and ones. Whatever we instruct a computer to do, it transmits it or it translates that language or that information to its language. Then the third thing that the receiver do, it actually check for errors. This protocol checks for errors and correct them if possible and record data packed into the correct sequencing. And the last one, we talk about the data usage. These are the binary data which is interpreted by software and presented in a human readable form, and it can only display it on the screen. So the next communication. This slide, we talk about a computer can only understand digital signals, while communications channel carry analog signals. So for them to be understand each other, they need a modem in between them. So here on this point, we are actually talking about software and hardware. These are the modem that we need or that the module that the computer needs to understand between you and between a user and a computer. So this module actually modulates digital signal to analog signal for the telephone link to transmit on the receiving end, and the module demodulates the signal to digital signal, this receiving signal from the telephone line into signal for the receiving computer to the understanding the send of messaging. With that being said, data communication wouldn't be successful if there is no these hardware and software tools. So the important key here is that software and hardware tools plays a big role in data communication because it's the one that receives, it's the one that sends, and it's the one that transmits. Thank you.
Okay, good evening. My name is Mtuko Elizabeth, and I'm going to talk about how data can be checked for errors. How can we achieve that? We use parity bit. An extra bit is attached to check whether the transmitted message has an error. The parity bit is always added at the end of the bits. So we have 4 types of parity checking methods. We have even parity. Numbers of ones should always be even. If not have occurred, then an error would have occurred. 2, we have odd parity. Numbers of ones should always be odd. If not, then an error would have occurred. 3, we have mark parity. The parity bit should always be a 1. If at the destination it reaches as a 0, then an error must have occurred. Then lastly, we have space parity. The parity bit should always be a 0. If at the destination it reaches as a 1, then an error must have occurred. So that's all I have for you tonight. Thank you for watching. If you have any questions, just drop them in the comment sections and we will get back to you. Thank you for watching.